Question 2 is that this is actually this concept is from collisions, so which we will discuss in next week, but still because it is given two times I will try to discuss this, so try to get whatever you have understood. Okay, question is, two identical blocks A and B of mass m resting on a smooth floor are connected by light spring of natural length L and spring constant K with a spring at its natural length. A third block C, whose mass is m, is moving with a speed v along the line joining A and B, collides with A. The maximum compression in the spring is. Question is, there is a block C. This is moving with a velocity v. So it had striked a block A, which is connected with a string, and to the other end of the string you have B. Okay, spring is a natural length is L, and mass of the blocks are m, small m and small m. Is telling, of course, they are on the floor. So the floor is smooth. Okay, here we use the concept of collision, and that to conservation of a linear momentum, that is conservation of P. So as we told, if we take this block and this entire thing as a single system, when there is a collision, there is no external force. Of course, there is N, there is normal reaction between A and C, but that's an internal force when you take C, A, B as a single system. So, because there is no external force in the horizontal direction, I can conserve the momentums in the initial position and the final position. And remember, the maximum expansion or compression in a spring you can get when both blocks move with same velocity. Just remember this point, same. In these kind of situations you can get, when both the blocks are moving with same velocity, you can get maximum compression at that particular point. Fine. So let me conserve the momentum. Initial is m into v, and momentum of A0, B0, so I'm not writing there, that is equals to, let's say both blocks are moving at the time of maximum compression, both blocks are moving with same velocity, let's call that velocity v dash. So m v dash plus m v dash, that is equals to 2m v dash. So the velocities of the blocks will be how much? V dash equals to v by 2. And so if you conserve, because, and if you take W non equals to delta E, so we'll identify that because there is no friction, the only forces acting are gravity and normal reaction in the upward direction, it doesn't do any work. When C is in contact with A, so you have a normal reaction, but because we are taking them as a single system, so the work done by that will be 0, because that particular force will act for a very short time and it has no displacement. The force will not create any displacement, so the work done by that force is also 0. So finally your W non will be what? 0. So I can conserve my moment energies, mechanical energies in the initial position and the final moment. Okay, initially there is only one block moving, the two block C, and it has a kinetic energy. The value of that is half m v square, that is equals to, so block A rest, block B rest, spring is natural position initially, so no potential energy stored in the spring. The only energy is half mv square. Finally, of course, C will come to rest and A comma B will start to move, and there is a compression called X in the spring, so that is half k x square, so potential energy stored in the spring. And finally, both blocks have velocities, so half m v dash square plus half m v dash square, that is equals to half m v square equals to half kx square plus m v dash square. V dash square is how much? V square by 4. So we get what? 1 by 4 mv square equals to half k x square. So 2 times. So x is how much? X equals to v root over m by 2k. And this is your answer. So that is option 1. Thank you.